This video is called the Manpollo Project and is part of the expansion pack accompanying the original video, How It All Ends. This video is to address the concerns of all those who feel I've oversimplified something inappropriately in my risk management approach to climate change, represented by the grid in the video, How It All Ends, and that oversimplification can't be ignored because it would qualitatively change the outcome of our analysis. Generally, I got accused of being either incompetent or manipulative by simplifying, so here we'll answer that. So if you think I oversimplified inappropriately, here we'll make sure we don't do that by taking the full complexity head on and not shirking a single detail. So buckle your seatbelt. Regarding the grid, I've often heard objections such as, it's not that simple. What about the intermediates between no action and all-out action? What if climate change is happening, but we're not the ones doing it? What if climate change is happening and we're the ones doing it, but our actions don't stop it, or they make it worse? Don't we need more columns and rows to account for all of those possibilities? Okay, those are all valid, but before we explore them, I'll point out that if you first watch the videos, The Mechanics of Climate Change, Scare Tactics, and The Solution, you'll probably see how unfeasible those last three scenarios are. That is, how clear it is that we are the ones doing it, and that action would be only beneficial. And you might no longer be concerned with the need to include them as rows before using the grid to draw a conclusion about what to do. Also, independent of whether the science I explained in those three videos allays your concerns, the video Risk Management points out that the top scientific organizations in the world have publicly and explicitly said, yes, the globe is warming, yes, humans are the ones doing it, and yes, our actions will have an effect, a good one, but we better get on it quick. So the short answer to the objections is, who are you and I to argue with the top scientists about the science? But some of you still don't trust the objectivity or competence of those scientific authorities, so we'll take on all those what-ifs head on and include them in our pathetically oversimplified grid. Ready? Here we go. Holy shit, it exploded! Across the top, we've replaced our dichotomous two columns of action and no action with a gradation of 5 different columns ranging from all-out action to no action and in between. Down the side, we've got 3 different factors to consider. One is global warming true or not? 2, if it's true, is it anthropogenic or human caused? And 3, what effects would our actions have, positive, negative, or neutral? So down the side we have 9 different scenarios. First one is global warming is true and it is caused by humans and our actions would have a positive effect. How about if it's true and we cause it but our actions would have no effect? Or it's true and we cause it but our actions would actually screw it up worse. Then we got it's true but it's not us doing it but we could have positive effect. It's true but we're not the ones doing it and our effect we would have no effect, neutral effect. It's true, we're not the ones doing it and we can screw it up even worse by taking action. And then down here we've got global warming isn't happening at all, so it's false. It's meaningless to ask whether it's caused by humans or not if it's not actually happening. And then positive, negative, and neutral effects here. And you'll notice that our 3 factors of 2 times 2 times 3 turned out to be 12, but we collapsed that into 9 because it's moot to talk about whether it's anthropogenic or not if it doesn't really exist. Okay, so that gives us a grid with 45 boxes. Into each one of these 45 boxes we put our different economic, environmental, social, political, and public health scenarios. If you recall from our expected value discussion from the video Risk Management, you might think we would then assign to each box a number to represent the consequence if that scenario happened. In this case, the cost to us. Not just the economic cost, but also some sort of quantified measurements of the various forms of suffering or benefit. But if you remember in that video, I pointed out how each box actually contains a range of possible consequences, and that to simplify our expected value calculation, we purposefully neglected to take into account that range, and instead just took the feasible worst-case scenario. Up here and down here were the ones we mainly looked at. This led a number of people who looked at the simplified grid to claim that column B was the better bet, because they forgot that this was just a simplification, and therefore they assumed that choosing column A doomed us to economic harm, no matter how the truth of global climate change played out, because we put in economic harm up here as a result of our spending, so therefore it must show up down here, therefore choosing column A dooms us to economic harm, therefore B is the better choice because it's the only one that has a box that we like the look of. Well, in order to address that, we just need to point out that once we unpack the simplicity, it's clear from what I shared in the videos Risk Management and Get What You Want, choosing column A only brings with it the possibility of economic harm, not the certainty. As you saw in those videos, long and conscientious searching on my part turned up exactly 0 economic doomsday scenarios from credible sources for this box. All the economic doomsday stories turned out to be simple conjecture from people at the very bottom of our credibility spectrum. And in fact, a number of quite credible sources, including industry leaders in the U.S. Climate Action Partnership, assert that column A quite likely leads to economic growth. So that should get us over our economic phobias surrounding column A and the boogeyman of government action. So if we're sincerely trying to not oversimplify here, what we need to do is going to get a little bit complicated. Fortunately for us, the tool of expected value is scalable and can be applied recursively. So what we'll do is we'll go inside of each box and look at the full range of possible consequences. Say in here, all the way from global depression to wild economic boom. And then we'll assign numerical values to each one of those possible consequences. Now, to stay backwardly compatible with our previous oversimplification, let's still represent consequences that cause suffering as positive numbers. The greater the magnitude, the greater the suffering or impact. And let's set 0 as neutral, no deviation from the norm. Counterintuitively, though, that gives us negative numbers for good consequences, like an economy boosted by innovation. But we can handle that. That's why we're here instead of stopping at the oversimplified 4-boxer, right? So next, we'll multiply each of the possible consequences in the box by the probability of each of those happening and sum those up to get the expected value for that box as a whole. Now, that gives us the single number we're looking for to give as a consequence for one box. And that replaces the worst case scenario that we had assumed to use as a consequence for that box in our previous oversimplified graph, which is what had caused some people to be confused and conclude that column A doomed us to economic harm no matter what. So we've taken care of that problem because we've introduced the probabilities back in. And there's no dooming anywhere, it's just probabilities and expected value. Then we'll calculate the expected value for the whole column by multiplying the consequences of each box, again, really just the calculated expected value of that box, by its probability taken from the rows on the side. And then we'll sum up those 9 products to get the expected value of the column as a whole. You'll recognize that's this exact same process of taking the sum of a series of products that we did inside of each box, illustrating the very slick recursive nature of the expected value. It's a pretty cool tool. Then we'll move over and do that exact same process for the next column and the next and the next. That will eventually give us an expected value assigned to each level of potential action, and we finally get the satisfaction of simply sitting back, looking at 5 numbers and asking which one is the closest to negative infinity. And that's the column that's the best choice for us, because that will tell us how much suffering we can expect if we choose that column. Now remember, again, to stay consistent with our original grid for the masses 4-boxer, 0 is neutral, positive numbers are suffering, and negative numbers are actually benefits. So the greatest benefit comes from the number that is farthest to the left on a number line. Closest to negative infinity. Instead of talking larger, smaller, because then you get confused with sign and magnitude. And remember, there's no guarantees because there were probabilities or probabilities layered in here. But the expected value is a well-proven tool used by businesses all the time, and it's the best we got here. Okay, so let's get started. Oh, and you'll recognize, of course, that the probabilities of all of our rows are going to need to sum up to exactly 1 if we're trying to be thorough and not neglect any scenarios. That 1, of course, represents the fact that we have a 100% chance of something being true. So if they sum to 1, that tells us that we haven't missed any cases, and we haven't oversimplified and dropped a case about what might happen. Also, it means that the absolute probabilities we distribute across these rows will handily function as relative probabilities, as in how much more likely is this row than this row. Okay, one other thing. You know how we will, for this process inside each box, we will need to do the whole range of possible economic consequences for a single box? We'll need to do that an identical process for each of the other factors besides economic, because there are probably things besides economic numbers that we might want to factor into our happiness, don't you think? But for the first time through, I'd suggest we limit ourselves to the factors of economic, environmental, social, political, and public health scenarios, since those will probably be the easiest for us to quantify and probably have the greatest bearing on our standard of living. At the end, if we have a close tie between 2 columns, then we can go back in and add some other factors in order to refine our answer. So we're not oversimplifying here, we're just doing a first pass through, and if the answer's not clear, then we can go back in and add some more factors. And for each one of those factors, let's break it into a reasonable five cases. So for the economic consequences of this box, we can say we got 5 cases, all the way from global depression to wild economic boom, neutral, and then 2 intermediate cases there. So that gives us 5 cases times 5 factors times 45 boxes, or a little over 1,100 numbers we've got to agree on to quantify the consequences, and an equal number of probabilities to assign. So I'm going to have to write kind of small because we got to fit in 2,200 numbers on this. You might have to squint. Sorry about that. And you might want to go get an energy drink because this may take a while. Okay, ready?